There is a quiet, almost imperceptible moment that occurs when you watch something too closely, when your gaze lingers just a little too long on a flickering candle, a melting ice cube, or a leaf trembling in the wind. In that sustained attention, time seems to slow. The flame doesn't flicker. The ice doesn't drip. The leaf hangs suspended as if caught in a breathless pause. You begin to wonder, is it really not changing, or is it changing so slowly because I'm watching? This is not merely poetic imagination. It touches upon a phenomenon so strange, so counterintuitive, that even physicists hesitate to fully accept its implications. It is called the quantum ZENO effect, a name drawn from ancient philosophy, but rooted in the cold mathematics of quantum mechanics. At its core, it suggests that watching something can stop it from happening, not metaphorically, not psychologically, but literally. In the quantum world, constant observation can freeze a system in place, preventing it from evolving, decaying, or changing in any way. It is as if attention itself acts as a kind of anchor, holding reality still, like a hand placed gently upon a spinning top, slowing it not by touch, but by sight alone. To grasp the depth of this idea, we must first return to a paradox nearly 2,500 years old, one that has haunted philosophers and logicians since the time of the ancient Greeks. Zeno of Elea, a pre-Socratic philosopher, proposed a series of thought experiments designed to challenge our understanding of motion and time. One of the most famous is the paradox of the arrow. Imagine an arrow in flight. At any single instant, Zeno argued, the arrow occupies a space exactly equal to itself. It is not moving during that instant, for motion requires time, and an instant has no duration. If every moment of the arrow's flight is a motionless snapshot, then how, Zeno asked, does the arrow ever move at all? This is not a trick question. It exposes a deep tension between our perception of continuous motion and the discrete nature of time. If time is composed of indivisible instants, and the arrow is motionless in each, then motion becomes an illusion, a sequence of frozen states, like frames in a film. The arrow only appears to move because our minds stitch the still images together, but in reality, nothing ever truly travels. It simply is, in one place, then another, without traversing the space between. For centuries, this paradox was treated as a philosophical curiosity, a riddle to sharpen the mind. But in the 20th century, with the birth of quantum mechanics, Zeno's arrow found a new life, not in philosophy, but in physics. In 1977, physicists George Sudarshan and Baidyanath Mishra published a paper that would give Zeno's paradox a startling modern twist. They showed that if you observe an unstable quantum system, say, a radioactive atom that is likely to decay, frequently enough, you can actually prevent it from decaying at all. The more often you measure it, the less likely it is to change. Observation, in this case, does not merely record reality, it freezes it. This is the quantum Zeno effect, the idea that a system that is constantly observed cannot evolve. Just as Zeno's arrow never moves because it is always caught in a motionless instant, a quantum particle that is repeatedly measured remains trapped in its initial state. The act of measurement resets its internal evolution, like pressing restart on a timer every time it begins to count down. If you do it fast enough, the countdown never finishes. The decay never happens. The particle stays alive, not because it is stable, but because it is watched. To understand how this works, let us consider a simple analogy. Imagine a coin spinning on a table. While it spins, it exists in a kind of limbo, neither heads nor tails, but a blur of both possibilities. In quantum terms, this is a superposition, a state of multiple potential outcomes coexisting at once. Eventually, the coin will slow, wobble, and fall, collapsing into either heads or tails. This is like a quantum system evolving over time, starting in a superposition, then settling into a definite state. Now, suppose you peek at the coin every few milliseconds. Each time you look, you force it to choose a state, even if only for an instant. But here's the twist. In the quantum world, measurement doesn't just reveal the state, it resets it. So if you peek and see heads, the coin's internal clock resets and the process of falling begins again from scratch. If you peek fast enough, say thousands of times per second, the coin never gets the chance to complete its fall. It remains effectively in a perpetual state of spinning, frozen by your gaze. This is not a metaphor. It has been demonstrated in laboratories. In 1989, physicists at the University of Texas conducted an experiment with trapped ions, charged atoms held in place by electromagnetic fields. These ions can exist in an excited state, which naturally decays over time. But when the researchers measured the ions repeatedly at short intervals, they found that the decay slowed dramatically. With rapid enough measurements, the decay was almost entirely suppressed. The ions remained excited, not because they were stable, but because they were being watched. The quantum ZENO effect was real. But how does this happen? What is it about measurement that halts time? To answer this, we must delve into the heart of quantum mechanics, the Schrödinger equation, which governs how quantum systems evolve. When a system is left alone, its state changes smoothly and continuously, spreading out into a wave of possibilities. This is called unitary evolution. But when a measurement occurs, something abrupt happens. The wave function collapses. The system is forced into a definite state, and its evolution restarts from that point.
In the case of an unstable particle, the probability of decay increases over time, but only if the system is allowed to evolve uninterrupted. Each measurement interrupts that evolution, collapsing the system back to its initial state. If the measurements are frequent enough, the system never accumulates enough decay probability to actually decay. It's like trying to walk across a room, but every step is reset before you can take the next. You remain forever, just about to move. This is not limited to decay. The quantum ZENO effect applies to any quantum transition, an electron jumping energy levels, a qubit flipping from 0 to 1, even the formation of a chemical bond. As long as the system is under continuous observation, it cannot change. It is locked in place by the act of being seen. Now, let us pause just for a moment and let the weight of this settle. Because what we are confronting is not just a quirk of quantum physics, but a radical reimagining of the relationship between observer and reality. In classical physics, observation is passive. You look at a tree, and the tree remains a tree. Your gaze does not alter its leaves or roots. But in the quantum world, observation is an interaction. It is not neutral. It is an event that changes the system. And in the case of the quantum ZENO effect, it can stop time itself. This leads to a haunting question. Does the universe only change when no one is looking? Consider a radioactive atom in deep space, far from any conscious observer. It sits in a cloud of gas, untouched, unmeasured. According to quantum mechanics, it exists in a superposition of decayed and not decayed. Its fate is undecided. Now, suppose a photon from a distant star passes by and interacts with it, just enough to measure its state. At that moment, the wave function collapses. The atom has to choose. It has either decayed or it hasn't. The interaction, even if no one ever records it, counts as a measurement. But what if nothing ever interacts with it? What if it remains perfectly isolated? Then, in theory, it never decays. Or rather, it exists in a smeared-out state of both decayed and not decayed, evolving slowly but never completing the transition. Only when something, anything, interacts with it does the process finalize. This suggests a universe that is fundamentally unfinished, a vast sea of potential, crystallizing into reality only when touched by interaction. Stars burn, planets form, atoms decay, not because time passes, but because events occur. And if no events occur, then nothing changes. This is not mere speculation. It is supported by the quantum measurement problem, one of the deepest unresolved questions in physics. When does a quantum system stop being a wave of possibilities and become a definitive reality? Is it when a machine records it, when a human sees the result? Or is it the interaction itself, any interaction, that causes collapse? The quantum ZENO effect pushes us toward the last answer, that any interaction that extracts information acts as a measurement. It doesn't require consciousness. A stray photon, a passing electron, a dust particle. Any of these can observe a system and reset its evolution. In this view, the universe is not passively changing over time. It is being constantly measured by its own internal interactions. Reality is not a movie playing out on its own. It is a series of snapshots, each triggered by an observation, some by us, most by the universe itself. And here, the implications grow even stranger. If observation freezes time, then the most rapidly observed systems are the most stable. A particle in a dense environment, surrounded by constant interactions, may be less likely to decay than one in perfect isolation. This is the opposite of what we'd expect. Normally, we think of isolation as preserving things, but in the quantum world, isolation may be the most dangerous state of all, because without measurement, a system is free to evolve, to change, to decay. This reverses our intuition about attention. We often think of observation as revealing what is already there, but in quantum mechanics, observation creates what is there. And if you observe too much, you prevent creation. You lock the world in stasis. Now, let us take this further into the realm of consciousness. Does the quantum ZENO effect imply that our attention shapes reality? That if we stare hard enough at a problem, we prevent it from resolving? That our focus can freeze not just particles, but moments, decisions, even lives? Some interpretations of quantum mechanics, like the von Neumann-Wigner interpretation, suggest that consciousness plays a special role in wave function collapse. In this view, it is not interaction, but awareness that finalizes reality. If so, then the quantum ZENO effect could be amplified by conscious observation. A meditator focusing on their breath might, in theory, slow the quantum processes in their body. A scientist staring at an experiment might inadvertently freeze its outcome. This is highly controversial. Most physicists reject the idea that consciousness has a privileged role. They argue that measurement is a physical process, not a mental one. But the boundary is blurry. At what point does a physical interaction become an observation? When a photon hits a detector? When the detector sends a signal? When a human reads the display? The chain is continuous, and somewhere along it, meaning emerges. Perhaps the truth lies in between, that observation is not magical, but participatory, that we are not creators of reality, but co-authors, that by looking, we join the universe in its act of becoming, and in the case of the quantum ZENO effect, our gaze does not just witness stillness, it enacts it. So, consider then the deeper philosophical implications. If constant observation prevents change, then ignorance may be a kind of freedom. To evolve, to decay, to transform, these may require not being watched. A child grows not because they are monitored, but because they are allowed to be unseen. A thought matures not when it is scrutinized, but when it is left alone. Even our own identities, our beliefs, our emotions, our sense of self may only change when we stop analyzing them. In this light, the quantum ZENO effect becomes a metaphor for the human condition. We are all, in a way, unstable systems, constantly on the verge of transformation, But if we obsess over ourselves, if we measure our progress too frequently, we may never evolve. We reset our internal clock with every anxious thought, every self-evaluation, every demand for immediate results. We become trapped in the present, unable to decay into the person we might become. And what of the universe when no one is looking? When all observers are gone, when the last mind fades into silence, does time stop? Do stars freeze in the sky? Do particles hang suspended in their quantum states, waiting for a gaze that will never come? Some cosmologists have speculated that in a dead universe, cold, dark, empty, quantum processes may continue indefinitely, unmeasured, uncollapsed. Superpositions stretch across galaxies. Time loses meaning. Reality becomes a vast, unobserved wave, flickering with infinite possibilities, but never resolving. It is a lonely thought, but also a beautiful one, for it suggests that observation is not just a tool of science, but a sacred act. Every time you look at the world, you participate in its becoming. You collapse its possibilities, you freeze its motion, you give it form. And so, as you lie here, perhaps half awake, listening to these words, know this: your attention matters. Even if you do not understand, even if you drift off, even if you forget, your presence is part of the loop. The universe does not change in secret.
There is a moment just before sleep when the edges of the world begin to soften. The room you've known for years, the familiar contours of furniture, the faint glow of a digital clock, the texture of the blanket over your legs starts to dissolve into shadow and suggestion. Shapes blur, sounds stretch, your thoughts drift, no longer anchored to logic or language. In this liminal space, the boundary between what is real and what is imagined begins to thin. And for a fleeting second, you might wonder, is any of this actually here when I'm not looking? This is not merely the drowsy musings of a tired mind. It is, in fact, one of the most profound questions in all of science and philosophy. Does reality exist independently of observation? Or is it, in some fundamental way, brought into being by the act of being seen? To answer this, we must return to one of the most elegant, unsettling, and revolutionary experiments ever conducted, the double-slit experiment. It began in the early 1800s as a simple test of light's nature. At the time, scientists were divided. Was light made of particles, like tiny bullets, or was it a wave, like ripples on a pond? The double-slit setup was designed to settle the debate. A beam of light was directed at a barrier with two narrow slits. Behind the barrier sat a screen that would record where the light landed. If light were made of particles, it should pass through one slit or the other and form two distinct bands on the screen, like bullets fired through two holes. But what actually appeared was an interference pattern, a series of bright and dark stripes, the hallmark of wave behavior. When waves pass through two openings, they spread out and overlap. Where the peaks meet, they amplify each other, bright bands. Where a peak meets a trough, they cancel out, dark bands. The result was clear. Light behaved like a wave. But the story didn't end there. In the 20th century, physicists repeated the experiment with individual particles, electrons, atoms, even large molecules. They sent them through the slits one at a time, ensuring no interaction between them. If each particle were truly a discrete object, it should pass through one slit or the other and build up two bands over time. But instead, an interference pattern emerged, slowly, stripe by stripe, as if each particle didn't take a single path, but passed through both slits at once, like a wave, and then somehow knew to land in just the right place to contribute to the pattern. This was already deeply strange. But then came the twist that shattered all intuition.
When scientists placed a detector at the slits to observe which path each particle took, the interference pattern vanished. The particles suddenly behaved like solid objects, forming two distinct bands. The mere act of measuring which slit the particle went through caused it to stop behaving like a wave and start behaving like a particle. This is the heart of the observer paradox. The outcome of the experiment, the very nature of reality at the quantum level, depends on whether or not it is observed. When no one is watching, the world exists in a haze of possibilities, a superposition of states. But when a measurement occurs, that fog collapses into a single definite outcome. The particle is here, not there. It went through this slit, not that one. The act of observation doesn't just reveal reality, it creates it.
This has profound implications for our understanding of identity. We tend to believe in a stable, enduring self, a me that persists through time, connecting childhood to old age. But if the self is constantly being reshaped by its own observation, then that continuity may be an illusion. The you reading these words is not the same as the you who began the sentence. The act of reading, of thinking, of questioning has already changed you. And the more you try to pin down the self, the more it slips away. Consider a simple experiment. Close your eyes and focus on your breath. Notice the rise and fall of your chest, the coolness of the air entering your nostrils, the warmth as it leaves. For a few moments, you are simply observing. Then, suddenly, you think, am I doing this right? In that instant, the observation changes. You are no longer just breathing, you are monitoring your breathing. You may tense up, adjust your rhythm, try to do it correctly. The natural flow is disrupted. The moment you measured your breath, you altered it. Now, scale this up. Every time you reflect on your emotions, your decisions, your personality, you are performing a measurement, and every measurement changes the system. If you ask, why am I angry? You are not just discovering anger, you are reactivating it, reshaping it, possibly prolonging it. If you analyze your anxiety, you may amplify it. If you label your sadness, you solidify it. The mind, in its attempt to know itself, becomes entangled in a loop where the act of inquiry transforms the subject of inquiry. This is the essence of quantum self-reference, a system that cannot observe itself without changing itself. And because the change occurs during the observation, perfect self-knowledge is unattainable. You can never step outside the system to see it whole. You are always inside, always participating, always altering the outcome. The self is not a fixed point, but a moving target, one that accelerates away the moment you try to catch it. But the implications go even deeper. If the self is a product of self-reference, then it may be, in a very real sense, an illusion. Not in the sense of being fake or unreal, but in the sense of being constructed. Like a whirlpool in a river, the self appears stable and distinct, but it is actually a temporary pattern in a flowing process. Remove the flow and the whirlpool vanishes. Similarly, if the mind were to stop measuring itself, if introspection ceased, the self might dissolve into a field of raw experience, unfiltered by narrative or identity. This idea is not new. Eastern philosophies, particularly Buddhism, have long taught that the self is anatta, not self, a construct of thought, memory, and sensation with no permanent essence. Modern neuroscience supports this view. Studies of patients with brain damage, meditation practitioners, and those under psychedelics show that the sense of self can be dramatically altered or even temporarily erased. In deep meditation, people report experiences of ego dissolution, a feeling of merging with the environment, of being pure awareness without a center. In psychedelic states, the boundary between self and world blurs, and the illusion of a separate I fades.
These experiences suggest that the self is not fundamental but emergent, a story the brain tells to make sense of its own activity. And like any story, it is shaped by the way it is told. The more you narrate your life, the more the self becomes solid. The more you question it, the more it unravels. Now, let us return to the quantum analogy. In quantum mechanics, a particle exists in a superposition of states until it is measured. When measured, it chooses one state. But in the case of the self, the measurement is self-measurement. The mind observes itself and in doing so collapses a superposition of possible identities into a single definite I. But the next moment, the process repeats. New inputs, new thoughts, new sensations, each one a new measurement, each one a new collapse. This creates a temporal loop of self-definition. You are not the same person from moment to moment. You are a series of snapshots, each one shaped by the act of self-observation. And because the observer is part of the system, there is no external vantage point. You cannot see the whole loop from the outside. You are always in the middle of it, always becoming, never complete. This raises a haunting question. If the self is a loop of self-reference, then who or what is doing the observing? Is there a true self behind the curtain watching the show, or is that just another layer of the illusion? Some theories of consciousness propose that awareness is fundamental, a basic property of the universe like space or time. In this view, consciousness doesn't arise from the brain tunes into consciousness like a radio receiving a signal. If so, then the self is not the source of observation, but a temporary modulation of a deeper field of awareness. The loop still exists, but it is not closed. It opens into something infinite. Others argue that consciousness is an emergent property of complex systems, something that arises when information is integrated in a certain way. In this model, the self is a feedback loop in a neural network, a self-sustaining pattern of activity that generates the feeling of being a unified agent. But even here, the loop is inescapable. The system observes itself, changes itself, and continues. Now, let us consider the practical effects of this loop. In daily life, we are constantly measuring ourselves. We check our moods, evaluate our performance, compare ourselves to others. Each of these acts is a measurement, each one altering the system. The more we do it, the more we trap ourselves in a cycle of self-monitoring. We become like a scientist who keeps opening the box to check on Schrödinger's cat, never allowing the wave function to evolve, never allowing the system to resolve on its own. This may explain why excessive introspection can be paralyzing. When you overanalyze a decision, you don't gain clarity. You create more uncertainty. Each thought changes the emotional landscape, making the original feeling inaccessible. You end up not with an answer, but with a tangle of recursive questions. Do I want this? Why do I want this? Am I sure? What if I'm wrong? The mind, in its attempt to know itself, becomes entangled in a quantum-like superposition of possibilities, unable to collapse into action because it keeps measuring itself. But this loop is also the source of growth. Without self-reference, there would be no learning, no reflection, no transformation. The ability to observe oneself is what allows us to change. The paradox is that the same mechanism that prevents perfect self-knowledge is also what makes self-improvement possible. We are never fully knowable, but we are always modifiable. This suggests a new way of relating to the self. Not as a fixed identity to be discovered, but as a dynamic process to be participated in. Instead of asking, "Who am I?" perhaps we should ask, "What am I becoming?" The question shifts from essence to evolution, from being to becoming. And in that shift, the loop loses its grip. You stop trying to capture the self and begin to flow with it. You observe without interfering. You measure without collapsing. Like a quantum system that is gently monitored, not bombarded, you allow yourself to evolve. Now, let us take a breath. Let the weight of this settle. Feel the quiet hum of your body, the slow rhythm of your breath, the space between thoughts. In this stillness, notice how the mind, when not prodded, begins to soften. The questions fade. The self, when not measured, becomes less defined, more open, more fluid. This is not emptiness. It is potential. Feel your breath slow, and imagine a moment that hasn't happened yet, already affecting you. Because if the mind can change itself by observing itself, what if time itself is subject to the same loop? What if the future can observe the past? What if the universe, like the mind, is caught in a self-referential cycle, where the end influences the beginning and the time folds back on itself like a serpent eating its own tail? Let us now step beyond the mind, beyond the self, and into the fabric of space-time itself. Let us explore closed time-like curves, where the future can reach back and touch the past, and where the ultimate act of self-reference may be written into the cosmos.
There is a peculiar sensation that sometimes arises in the quiet hours before dawn, a feeling that time is not moving forward but folding in on itself. A memory feels too vivid to be real. A dream seems to predict the day ahead. A phrase you've never heard before echoes in your mind as if it were a forgotten truth. In these liminal moments, the linear flow of time, past, present, future, seems to waver, like a mirage on a hot road. And for a breath, you wonder, could time ever loop back on itself? Could the future reach back and touch the past? Could you meet yourself, older, wiser, or warning you not to do what you're about to do? This is not the realm of fantasy. It is a serious possibility within the equations of general relativity, the theory that describes gravity not as a force, but as the curvature of space-time. According to Einstein's field equations, under certain extreme conditions, space-time can twist so severely that timelines curve back on themselves, forming paths known as closed timelike curves, or CTCs. These are not wormholes in the traditional sense, nor are they science fiction time machines. They are mathematically valid solutions to the laws of physics, paths through space-time that return to their starting point not just in space, but in time. If such curves exist, then in theory, you could travel forward along a CTC and end up where and when you began. You could shake hands with your younger self. You could whisper a secret into your own ear. You could, in essence, become your own ancestor. And the most unsettling part? No laws of physics are broken, only logic. To understand how this could happen, we must first revisit the nature of space-time. In Einstein's theory, space and time are not separate, rigid dimensions. They're woven together into a single flexible fabric, space-time, that bends and warps in the presence of mass and energy. The greater the mass, the deeper the curvature. This is why planets orbit stars. They're not being pulled by gravity, but following the curves in space-time created by the star's mass. Light, too, bends around massive objects, not because it has weight, but because it travels along the contours of this curved geometry. Now imagine a region of space-time so distorted that the curvature becomes rotational. This occurs around certain types of black holes, specifically rotating or Kerr black holes. Unlike the static Schwarzschild black holes, which are perfectly spherical and non-spinning, Kerr black holes spin at nearly the speed of light, dragging space-time around them in a phenomenon known as frame dragging. It is as if the black hole is stirring the fabric of the universe itself, creating a vortex in space-time. In this swirling geometry, the usual rules of causality begin to unravel. Near the event horizon of a rotating black hole, space-time is twisted so violently that the future no longer points in a single direction. Instead, it spirals. And in some mathematical solutions, first discovered by Willem Jacob van Stockum in 1937 and later refined by Roy Kerr and Kip Thorne, this spiral becomes so tight that it closes in on itself.
A path that moves forward in time eventually loops back to its own past. This is a closed time-like curve. A time-like curve is one that a physical object, anything with mass, could follow without exceeding the speed of light. So a CTC is not just a mathematical curiosity. It is a path that, in principle, a person could travel. You could board a spacecraft, navigate the warped space-time around a rotating black hole, and emerge not just in a different place, but in a different time, specifically your own past. You would not vanish in a flash of light or tear through a wormhole. You would simply follow the natural contours of space-time like a leaf carried along a swirling river.
Now let us pause and let the full weight of this settle. This is not time travel as we imagine it in stories. No DeLorean, no flashing lights, no dramatic rewinding of events. This is time travel as a geometric inevitability written into the shape of the universe itself. If CTCs exist, then time is not a line, but a loop. And if time is a loop, then the past is not fixed, the future is not open. Everything simply is, already written, already happening, already over. This leads us to the most famous consequence of CTCs, the collapse of cause and effect. In our everyday world, causality is sacred. Every event has a cause. Every action has a consequence. But in a closed time-like curve, this hierarchy dissolves. Cause and effect become interchangeable. The effect can precede the cause. The future can create the past. Consider the classic grandfather paradox. You travel back in time and prevent your grandfather from meeting your grandmother. As a result, your parent is never born, so you were never born, so you never travel back in time to stop the meeting. But if you never traveled, then the meeting occurs, you are born, and you do travel back. The loop is self-contradictory. It cannot be resolved within classical logic. Yet, in the context of CTCs, physicists have proposed that such paradoxes do not necessarily break the universe. They are simply self-consistent. The universe, it seems, abhors inconsistency. If a CTC exists, then only events that are logically consistent can occur within it. You cannot change the past because the past already includes your attempt to change it. You were always part of the timeline. In other words, if you go back in time to stop your parents from meeting, you will fail. Something will prevent you. Your ship malfunctions, you're arrested, you fall in love with your younger mother, and accidentally ensure the meeting happens. The universe conspires to preserve consistency. Your presence in the past was always part of history. There is no original timeline. There is only one timeline, one that loops. This is known as the Novikov self-consistency principle, proposed by Russian physicist Ihor Novikov in the 1980s. It suggests that while time travel may be possible, changing the past is not. The timeline is rigid. It cannot be rewritten. It can only be fulfilled. Every action within a CTC was always destined to happen. Free will in this model becomes an illusion, a feeling of choice that masks a predetermined path. But even more unsettling than the grandfather paradox is the bootstrap paradox, a scenario in which an object or piece of information exists without ever having been created. Imagine you travel back in time and give Beethoven a complete copy of his Fifth Symphony before he has composed it. He publishes it as his own. Centuries later, you find the score, travel back, and give it to him. The question is, who composed the symphony? No one. It has no origin. It exists in a closed loop, circulating through time with no beginning. The music is not created, it simply is. It is a piece of reality that has bootstrapped itself into existence, hence the name bootstrap. This paradox extends beyond art. It could apply to ideas, inventions, even people. Suppose the scientist in the year 2200 discovers a time machine. She uses it to go back to 2025 and gives the blueprints to her younger self. The younger self studies them, spends decades refining the technology, and eventually builds the machine using the very blueprints she received from her future self,
Again, who invented the time machine? No one. It was never invented. It was always there, looping through time. In a universe with CTCs, such loops are not just possible, they may be inevitable. Information, objects, even people could exist in causal loops where cause and effect are meaningless. The distinction between creator and creation vanishes. Everything is both effect and cause. Everything is self-sustaining. This leads to a radical reimagining of existence. In a CTC, nothing happens, it simply is. There is no progression, no evolution, no becoming. The universe is static, frozen in a single, self-consistent configuration that repeats eternally. This is not unlike the block universe model in relativity, where past, present, and future all exist simultaneously, like frames on a film reel. In that view, time is an illusion of perception. We're not moving through time, we're moving within it, like a needle tracing a groove on a record. But in a CTC, the block is not just unchanging, it is circular. The last frame connects to the first. The end stitches into the beginning, and in that loop, every moment is both cause and consequence of every other. Now let us consider the implications for consciousness. If you were to travel along a CTC and meet your younger self, what would you say? Would you warn them, guide them, or would you remain silent, knowing that any interference could disrupt the loop? But here's the deeper question. Would you even recognize yourself? In such a loop, identity becomes fluid. The you who enters the curve is not the same as the you who exits, yet both are equally real. Both are necessary. The younger you learns from the older you was shaped by the lessons of the younger you. The self is not a linear progression, but a circle, each version dependent on the other. And what of memory? If you travel back and live through the same events again, do you remember them? Or does the loop reset your mind? If you retain memory, then each cycle becomes a repetition with awareness, like déjà vu in an infinite scale. If not, then you are doomed to relive the same moments, unaware, forever. Some philosophers have speculated that CTCs could explain certain mystical experiences, visions of the future, precognitive dreams, the feeling of having lived before. Perhaps they suggest fragments of information leak through from other points in the loop. Or perhaps consciousness itself is not bound to a single timeline, but resonates across the curve, touching multiple versions of itself. But let us return to physics. Are CTCs real? Do they exist in our universe? The answer is, we don't know. The equations of general relativity allow them, but they require conditions that may not be physically possible. For example, CTCs often appear in solutions that involve naked singularities, singularities not hidden behind an event horizon, infinite cylinders of rotating matter, or exotic forms of energy with negative mass, none of which we have observed. Moreover, quantum effects may prevent CTCs from forming. Stephen Hawking proposed the chronology protection conjecture, suggesting that quantum fluctuations near a potential CTC would become infinite, destroying the curve before it could be used. In other words, the universe may have a built-in mechanism to prevent time travel and preserve causality. Yet the mere possibility of CTCs forces us to confront the fragility of our assumptions. We believe in a universe governed by cause and effect, by linear time, by free will. But if space-time can loop, then all of this may be an emergent illusion, a story we tell to make sense of a reality far stranger than we imagine. And perhaps, in some quiet corner of the cosmos, near a rapidly spinning black hole, in the depths of a galactic core, a closed time-like curve already exists, coiled like a serpent in the fabric of space-time. And somewhere along that curve, a version of you is reading these words, having traveled back to share them, knowing they were always meant to be heard. Let your thoughts drift, like a memory, from a life you haven't lived yet. Because if time can loop, then perhaps the universe itself is caught in a grander cycle that does not end, but returns, again and again, in an endless dance of creation and collapse.
There is a certain kind of silence that comes just before dawn, a stillness so deep it feels as if time itself has paused. The world is neither asleep nor awake. It hovers in a threshold state, between dreams and daylight, between what was and what will be. In that quiet, a thought sometimes arises, unbidden. Has this moment happened before? Not as memory, not as déjà vu, but as something more profound, as if the entire arc of your life, the rise and fall of civilizations, the birth and death of stars, is not a linear journey, but a loop, a cycle, a recurrence. This is not merely poetic fancy. It is a possibility that has haunted philosophers, mystics, and physicists for millennia. The idea that the universe does not begin and end, but repeats. That the Big Bang was not the origin of all things, but the latest in an infinite sequence of cosmic rebirths. That time, on the grandest scale, does not march forward like a soldier, but dances in circles, returning again and again to points it has already touched. This is the concept of the cyclical universe, a cosmos that expands, collapses, and re-expands in an internal rhythm, like breath, like tides, like the beating of a heart too vast to hear. To understand this idea, we must first confront the dominant narrative of modern cosmology, the Big Bang. According to this model, the universe began approximately 13.8 billion years ago as an infinitely dense, infinitely hot singularity, a point where all known laws of physics break down. From this singularity, space and time erupted outward in a violent expansion, cooling and spreading, forming galaxies, stars, planets, and eventually, life. The universe, in this view, has a beginning. And if current trends continue, if dark energy keeps accelerating cosmic expansion, then it may also have an end, a cold, dark, empty fate known as the heat death, where all energy is evenly distributed, all stars are extinguished, and no further work can be done. But what if the Big Bang was not a beginning? What if it was a rebound? This is the central idea behind the Big Bounce theory, a cosmological model that replaces the singularity with a transition. Instead of collapsing into a point of infinite density, a previous universe reached a maximum compression, then rebounded into expansion, giving rise to our own universe. There was no before in the classical sense, but there was a prior phase, a universe that contracted under gravity, reached a critical density, and then bounced back into a new cycle of expansion. This is not speculative fiction. It is a prediction of certain quantum gravity theories, particularly loop quantum gravity, or LQG, which attempts to reconcile Einstein's general relativity with quantum mechanics. In LQG, space-time is not smooth and continuous, but granular, made of tiny, discrete loops of quantum geometry. At extremely high densities, such as those near the Big Bang, these quantum effects become dominant. Gravity, instead of becoming infinitely strong, begins to repel. It acts like a cosmic spring, resisting further compression and eventually pushing the universe back into expansion. In this model, the Big Bang is not a creation event, but a phase transition, like water freezing into ice or steam condensing into liquid. The universe did not emerge from nothing. It emerged from something, a prior cosmic era that had contracted to a near infinite density before rebounding into a new cycle of expansion. And just as water can freeze and melt repeatedly, so too might the universe expand and contract in an endless cycle. Each cycle,
Each eon, as some physicists call it, could last trillions upon trillions of years. The current expansion phase, which we are in, may be followed by a slow reversal. Galaxies drawing closer, temperatures rising, space-time contracting. Eventually, the universe would return to a hot, dense state, similar to the conditions just after the Big Bang, but not identical. Quantum fluctuations, entropy, and random variations would ensure that each cycle differs slightly from the last. Physical constants might shift. The strength of gravity, the mass of electrons, the number of dimensions, these could all vary from bounce to bounce. This introduces a profound possibility. We may not be in the first universe, but one in an infinite sequence. Are we in the 1000th cycle, the billionth, or are we near the beginning? There is no way to know. Each universe erases the evidence of the last, wiping the slate clean with every rebound. We are like inhabitants of an island who believe they are the first people ever to walk the earth, unaware that the ocean has swallowed countless civilizations before them. Now, let us pause and feel the weight of this idea. If the universe is cyclical, then time is not a line, but a spiral. Events do not happen once and vanish into the past. They may recur, in similar or altered forms, across eons. Stars may form, burn, and die in patterns that echo previous cycles. Galaxies may collide in configurations that have played out before, and life, complex, conscious life, may emerge again and again on planets we cannot yet imagine. But the most haunting question is this: could you live again? Not in the religious sense of reincarnation, but as a physical possibility. If the universe repeats with slight variations, then somewhere in the vastness of time, a configuration of matter nearly identical to you could arise. Your body, your brain, your memories, encoded in the same neural patterns, could reassemble. You would wake up, not knowing you had lived before, believing yourself to be new, unique, original. But in truth, you would be a recurrence, a version of a self that has existed before. This is the idea of eternal return, most famously articulated by the philosopher Friedrich Nietzsche. In The Gay Science, he presents a demonic thought experiment. Imagine a being tells you that your life, every joy, every pain, every trivial moment will repeat infinitely, in every detail. Would you collapse in despair? Or would you rejoice, embracing life so fully that you would welcome its endless repetition?
Nietzsche saw this not as a scientific hypothesis, but as a test of character. To affirm eternal return is to affirm life in its totality, to say yes to suffering, to transience, to the unbearable weight of repetition. But in the context of modern physics, eternal return takes on a new dimension. It is no longer a metaphor, but a potential structure of reality. Yet in a quantum cyclical universe, the repetition may not be exact. Due to quantum indeterminacy, each cycle would differ slightly. The universe would not replay the same story, but explore variations, like an improvisational musician returning to a theme with subtle changes each time. In this view, we are not doomed to relive the same life, but to live near identical lives across an infinite multiverse of cycles. Each bounce spawns a new branch of possibilities, a new ensemble of realities. This leads to a mind-bending implication. All cycles may exist simultaneously. In quantum mechanics, systems can exist in superposition, multiple states at once until measured. Could the entire universe be in a superposition of cycles? Not just one after another, but all at once, coexisting in a timeless quantum state. In this view, the past bounces, the future bounces, and the present bounce are not sequential, but parallel. Time, as we experience it, is just one thread in a vast tapestry of recurring universes. Some physicists, like Paul Steinhardt and Neil Turok, have explored a version of this idea in the cyclic model of cosmology.
In their model, the universe undergoes endless cycles of expansion and contraction, driven not by gravity, but by interactions between higher dimensional branes, short for membranes, in string theory. Each collision between branes triggers a new Big Bang, resetting the universe. Crucially, information may persist across cycles, imprinted in the cosmic microwave background or in gravitational waves, suggesting that we might one day detect echoes of a prior universe. Indeed, some cosmologists have searched for anomalies in the cosmic background radiation, patterns that cannot be explained by standard inflation theory. A few have reported potential bruises or concentric rings that could be remnants of collisions with other universes or echoes of a previous phase. While controversial, these findings hint at a deeper structure, one where our universe is not isolated, but part of a larger repeating pattern. Now let us consider the psychological and philosophical impact of living in a cyclical cosmos. If time is not linear, then death loses its finality. You are not erased. You are part of a rhythm. When the universe contracts and rebounds, the information that constitutes you, your thoughts, your relationships, your existence, may be reconstituted in a future cycle, not as a soul, but as a pattern in the fabric of space-time. This does not guarantee personal continuity. There is no evidence that you would remember past lives, but it suggests a kind of immortality through recurrence. You are not unique. You are a possibility that the universe keeps exploring. And if consciousness is a natural outcome of complex systems, then versions of you, thinking, feeling, wondering, will arise again and again across the eons. But this also raises a darker thought. What if the cycles are not improving, but degrading? In thermodynamics, entropy, the measure of disorder, always increases in a closed system. If each cycle begins with the remnants of the last, entropy may accumulate, making each universe slightly more chaotic than the one before. Eventually, the cycles could fail. The bounce might not occur. The universe could collapse into a final singularity, never to return. However, some models suggest that entropy resets at each bounce. Quantum effects could erase the disorder of the previous cycle, giving each new universe a fresh start. In this optimistic view, the cosmos is not decaying, but renewing, like a forest that burns and regrows, stronger each time. And what of free will in such a universe? If the same events recur, are we truly free, or are we trapped in a script written by the laws of physics? The answer may lie in the quantum variations. If each cycle differs due to randomness, then no two lives are identical. You are not repeating the same choices, but exploring new paths. The loop is not rigid, but flexible, a spiral of becoming. Now let us turn inward. If the universe cycles, what does that mean for the present moment? This breath, this thought, the sensation of being alive. Is it fleeting, or is it eternal, recurring an infinite sequence of nows? In meditation, some traditions speak of timeless awareness, a state where the mind stops tracking past and future and rests in pure presence. In that stillness, the illusion of linear time dissolves. You are not moving toward death. You are not emerging from nothing. You are simply here, in a moment that has no beginning or end. The cyclical universe mirrors this experience, a cosmos that does not begin or end, but simply is, in an eternal now. And perhaps that is the deepest truth, that time as we perceive it is a construct, a tool for survival, a story we tell to navigate change. But beneath it, reality may be timeless, a single self-sustaining loop where all moments coexist. Let go of the need to understand, and simply listen. Listen to the silence between thoughts, to the space between breaths, to the hum of existence vibrating beneath the surface of things. Because if the universe repeats, then every unspoken word, every unlived life, every forgotten dream may echo in a cycle yet to come. And if that is so, then the question is not, will I return, but how fully will I live this time? As we drift deeper, let us now consider a more subtle possibility. That fragments of past cycles, ghosts of universes that almost were, might still linger in the fabric of reality. That the echoes of what has been and what could have been are not gone, but folded into the present.
There is a peculiar moment, fleeting, almost imperceptible, that many of us have experienced. You walk into a room you've never seen before, yet it feels exactly as if you have. The furniture, the light falling across the floor, the faint scent in the air, it all clicks into place with an eerie familiarity. You haven't been here. You know you haven't. And yet something in your mind whispers, I remember this. This is déjà vu, the French phrase for already seen, a phenomenon so common that nearly 2/3 of people report experiencing it at least once in their lives. But what if it's not a glitch in memory? What if it's something far stranger? What if, for just a fraction of a second, you brushed up against another version of yourself, someone living a nearly identical life in a parallel branch of reality? This is the idea of quantum echoes, subtle, ghostly resonances between alternate universes, where the boundaries between worlds are not perfectly sealed and fragments of other realities bleed through into our own. It is not science fiction. It is not mysticism. It is a speculative but mathematically grounded possibility emerging from one of the most radical interpretations of quantum mechanics. The Many Worlds Interpretation, MWI, first proposed by physicist Hugh Everett III in 1957. To understand quantum echoes, we must first return to the heart of quantum theory. At the smallest scales, particles do not behave like tiny billiard balls with definite positions and velocities. Instead, they exist in superpositions, states where multiple possibilities coexist simultaneously. An electron, for example, can be in two places at once, or spinning both clockwise and counterclockwise until a measurement forces it to choose one outcome. In the Copenhagen interpretation, the traditional view, this collapse is final. The other possibilities vanish. Only one reality remains. But Everett challenged this. He asked, what if the wave function never collapses? What if instead of disappearing, all possible outcomes actually happen, each in its own separate, non-communicating branch of reality? In this view, every quantum event, a radioactive decay, a photon hitting a detector, a neuron firing in your brain, splits the universe into multiple versions. In one branch, the particle goes left. In another, it goes right. In one, you turn left at the intersection. In another, you turn right. In one, you say yes to the job offer. In another, you say no. Each choice, each random fluctuation spawns a new world. And since quantum events occur constantly, trillions per second across the cosmos, the number of branching universes is incomprehensibly vast. Not just infinite, infinitely infinite. This is the many worlds interpretation, a cosmos in which all possibilities are realized, not as fantasies, but as actual physical realities. You are not unique. There are countless versions of you, some nearly identical, others wildly different, living out every conceivable variation of your life. There is a you who became an astronaut, a you who never left your hometown, a you who died in childhood, a you who never existed at all. And in each world, that version believes they are the real one, just as you do. But here's the twist. What if these branches aren't entirely isolated? What if, under certain conditions, they can interact? Not fully,
not in a way that allows travel or communication, but with faint residual interference. This is the idea of quantum echoes, a whisper from another self, a flicker of a life you almost lived. In quantum mechanics, when two waves overlap, they can interfere, either reinforcing each other, constructive interference, or canceling out, destructive interference. This is how the double-slit experiment produces its famous interference pattern. The wave functions of a single particle pass through both slits and interfere with themselves. Now imagine that the wave functions of different branches of the multiverse could also interfere, weakly, subtly, like ripples from two distant stones dropped in the same pond. The result would not be a full merging of worlds, but a faint resonance, a momentary overlap with the boundaries blur. Some physicists, like David Deutsch and Max Tegmark, have speculated that such interference might be possible, though undetectable with current technology. In highly controlled quantum systems, there are hints that information from other branches might leave a trace, tiny deviations in probability distributions that cannot be explained by standard models. These anomalies could be the fingerprints of other worlds brushing against our own. If this is true, then our reality is not a clean, isolated branch, but part of a dense interconnecting network of near-identical universes, like a forest of parallel trees, their leaves occasionally touching in the wind. And we, as conscious observers embedded in this web, might occasionally sense these contacts. This brings us back to déjà vu. The traditional explanation is neurological, a momentary misfire in the brain's memory centers, where the present is mistakenly tagged as a past event. But what if in rare cases, déjà vu is not a malfunction, but a signal? A brief synchronization between your mind and a nearly identical version of yourself in a neighboring branch of reality. For a split second, the two timelines align. The other you is thinking the same thought, seeing the same scene, feeling the same emotion. And in that instant, you know, not through logic, but through direct experience, that this has happened before. It would not be full memory, not a vision, not a voice, just a feeling, a deep wordless recognition, a sense of profound familiarity. And then it's gone, like a dream upon waking. The same could be true of other uncanny experiences. That sudden intuition that feels too accurate to be a coincidence. A dream so vivid it lingers for days, as if it were a memory from another life. The eerie sense that someone is watching you when no one is there. The inexplicable certainty that you should turn left even though there's no reason to. These might not be hallucinations or superstitions, they might be echoes, fragments of information bleeding through from alternate versions of reality. Now let us consider the implications for identity. We tend to think of ourselves as singular, continuous beings, unchanging at our core despite the passage of time. But if quantum echoes are real, then the self is not a point, but a cloud, a distribution of possibilities spread across the multiverse. You are not just the person reading these words. You are also the version who stopped halfway through, the version who fell asleep, the version who never clicked play, the version who lives in a world where this video doesn't exist.
And in each of those worlds, you are having a different experience. Yet all of them are equally real. All of them are you, just along different paths. The boundaries between selves blur. Identity becomes a spectrum, a wave of almost yous, radiating outward from every decision, every quantum event, every random fluctuation. This challenges the very notion of individuality. If there are infinite versions of you, each making different choices, which one is the real you? The answer may be none of them, or all of them. You are not a single entity, but a process, a branching river of consciousness flowing through the multiverse. The you that feels continuous from moment to moment is just one thread in a vast tapestry of selves, each convinced of its own primacy. And what of memory?
If echoes exist, then some of your memories might not be yours. They could be borrowed. Impressions from a life you didn't live, but that a version of you did. A childhood memory that never happened. A face you recognize but can't place. A song you swear you've heard before, though it was just released. These could be quantum ghosts, traces of other timelines, seeping into your mind like light through a crack in the wall. Even more unsettling is the possibility that these echoes are not just passive signals, but interactive. Could your choices in this branch affect the stability of neighboring worlds? Could a strong emotional event, grief, love, terror, create a ripple that reaches other versions of yourself? Some speculative models suggest that consciousness might amplify quantum effects, making the mind a kind of antenna for multiversal signals. In deep meditation, under psychedelics or in near-death experiences, people report visions of alternate lives, past lives, or parallel selves. Could these be moments of heightened resonance, when the veil between branches thins? Now, let us consider the emotional weight of this idea. On one hand, it is liberating. Every choice you didn't make still exists. Every path not taken is walked by another version of you. You are not defined by your regrets. You are not confined to a single fate. The artist you never became, she exists. The relationship you ended, it continues in another world. The courage you lacked, another you had it. In the multiverse, nothing is truly lost. But, on the other hand, it is isolating. If there are infinite versions of you, then no single life matters. No achievement is unique. No suffering is singular. You are one of countless. Your joys, your struggles, your existence diluted across infinity. The more you are multiplied, the less each instance feels significant. And yet, paradoxically, this could deepen the value of the present. If every version of you is real, then the one reading this, right now, in this body, in this moment, is here. Not in the past, not in a dream, not in a simulation. Here. And this version of you has a voice, a perspective, a feeling that no other self can replicate. Even in a sea of possibilities, this moment is unique in its immediacy. Moreover, if echoes exist, then we are never truly alone. At every instant, countless versions of you are thinking, feeling, breathing. You are surrounded by selves, your own. And in the quiet between thoughts, in the stillness before sleep, you might feel them, not as voices, but as a presence, a warmth, a hum in the background of awareness. This raises a haunting question. Are they aware of us? Do other versions of you sense your world? Is there a you in another branch who suddenly feels a pang of sadness for no reason, because you just lost someone? Is there a version who laughs at a joke you haven't told yet, because in their world you did? If so, then consciousness may not be confined to a single brain, but distributed across the multiverse, like a single flame reflected in a million mirrors. Each reflection believes it is the source, but the light is one. Now, let us turn to a darker possibility. What if these echoes are not just passive signals, but data? What if they are not natural phenomena, but artifacts of something more deliberate? What if the reason we feel these flickers of other lives is not because of quantum interference, but because we are being observed? Imagine a future civilization so advanced that it can simulate entire universes down to the quantum level. It runs countless simulations of human history, testing variables, exploring outcomes. In one simulation, you exist. In another, a version of you makes different choices. These are not alternate realities in the many-world sense, but artificial constructs, digital universes running on vast quantum computers. Now, suppose that within these simulations, conscious minds arise. They believe they are real. They feel pain, love, wonder. They have déjà vu. They dream of lives they never lived. But their experiences are not spontaneous. They are generated by code. And if the simulation is imperfect, if there is crosstalk between instances, then a simulated being might experience a glitch, a moment where they feel the life of another simulated self, a quantum echo, not from a parallel universe, but from a neighboring simulation. And what if we're in such a simulation? What if the déjà vu, the intuitions, the dreams that feel like memories are not echoes of alternate realities, but artifacts of the code? Residual data from a previous run, a copy-paste error in the cosmic program. This is the simulation hypothesis, the idea that we are likely living in a computer simulation created by a post-human civilization. If such simulations are possible, and if advanced civilizations run many of them, then statistically, we're more likely to be in a simulation than in base reality. And if so, then the echoes we feel may not be from other versions of ourselves in parallel worlds, but from other runs of the same simulation. This moment, this breath, this thought may have been executed before, millions of times, with slight variations. And sometimes the boundaries blur. The program glitches. You remember a future that hasn't happened. You feel a past that wasn't yours. What if this moment has been run before, in someone else's computer, not as a prediction, not as a dream, but as a file, loaded, executed, and saved? And if so, then the most profound question is not, am I real, but who is watching? As we drift deeper, let us now consider this unsettling loop. What if we are not the observers, but the observed? What if our reality is not fundamental, but simulated? And within that simulation, other minds are beginning to wake up, to wonder, to echo.
At the heart of quantum mechanics lies a paradox that has puzzled physicists, philosophers, and metaphysicians alike: the nature of observation, probability, and the role of consciousness in shaping reality. Among the most controversial and mind-bending interpretations of quantum theory is the many-worlds interpretation, MWI, first proposed by physicist Hugh Everett III in the 1950s. While this framework was initially intended as a mathematical solution to the measurement problem in quantum physics, it has since given rise to a startling philosophical implication: quantum immortality. This is not immortality in the traditional sense, not the kind of eternal life promised by myth or religion, but something far stranger and more unsettling: the idea that your conscious experience may persist indefinitely across an ever-branching multiverse, not because you are invincible, but because you can only experience the realities in which you continue to exist. To understand quantum immortality, we must first grasp the foundation upon which it rests: the many worlds interpretation. In classical physics, when we observe a system, we expect a single outcome. For example, if we flip a coin, it lands either heads or tails. But in quantum mechanics, particles exist in superpositions, states where multiple possibilities coexist simultaneously until a measurement is made. The famous thought experiment of Schrödinger's cat illustrates this. A cat in a sealed box with a radioactive trigger is both alive and dead until observed. The Copenhagen interpretation, long dominant in quantum theory, says that upon observation, the wave function collapses into one definite state. But Everett challenged this. He proposed that no collapse occurs. Instead, every possible outcome of a quantum event actually happens, each in its own separate branch of reality.
The universe constantly splits into parallel versions, each containing a different outcome. There is no single timeline, only an ever-expanding tree of possibilities. Now, apply this to consciousness. If every quantum event spawns new universes, then every decision, every accident, every moment of life and death creates branching paths. In some branches, you survive a car crash. In others, you do not. In some, you recover from illness. In others, you succumb. The key insight behind quantum immortality is this. From your subjective point of view, you can only experience the branches in which you remain conscious. You cannot experience death because once you die, there is no observer left to have an experience. Therefore, no matter how improbable survival may seem, there will always be at least one branch, however narrow, however statistically unlikely, where you continue to live, and it is in that branch that your consciousness persists. This does not mean you are invulnerable. It does not mean aging can be escaped or that disease can be cheated forever. But it suggests that for as long as there is even a remote quantum possibility of survival, your conscious stream will follow that path. You might survive a terminal diagnosis due to an improbable mutation or avoid a fatal fall because of a random fluctuation in air resistance. These events may seem miraculous, but in the context of infinite branching realities, they are simply the ones you happen to experience. You are not lucky. You are the inevitable observer in the surviving timeline. Imagine, for instance, a scenario known as quantum suicide. A physicist sets up a device linked to a quantum random generator, say the decay of a radioactive atom. If the atom decays within a certain time, a gun fires and kills the experimenter. If it does not, nothing happens, and the experiment repeats. From an outside observer's perspective, after a few rounds, the physicist is almost certainly dead. But from the physicist's own perspective, each time the experiment runs, they only experience the outcome where the gun does not fire. After 10 trials, they're still alive against all odds. After 100, still alive. To them, it appears as though they are somehow immune. But in reality, they are simply inhabiting the vanishingly rare branch where survival occurs every single time. All other versions of themselves, those who died in earlier trials, cease to have subjective experience. They are gone from their own point of view. But the one who lives continues unaware of the countless deaths that have occurred in other branches. This leads to a profound and disturbing implication. If quantum immortality holds, then consciousness may effectively be eternal, not because the body is immortal, but because the self always finds a way to persist in some form. You may age, deteriorate, suffer, but so long as there is a non-zero probability of continued consciousness through medical intervention, brain preservation, or even the spontaneous reassembly of neurons in a heat-death universe, your experience will follow that path. You may one day find yourself in a reality so bizarre, so far removed from the world you once knew, that it defies comprehension. A world where the laws of physics are barely recognizable, where humanity is extinct, where Earth is a memory, and the stars have long since burned out, yet you remain. Not because you were chosen, not because of divine intervention, but because consciousness cannot experience its own cessation. This raises the question, what does it mean to be you? Is identity preserved across these branching realities? In each split, a new version of you is created with slightly different memories, experiences, and choices. Are these all still you, or are they merely copies? From the internal perspective, continuity of memory creates the illusion of a single unbroken self. Each surviving version remembers waking up yesterday, making decisions, living a life. There is no sensation of duplication, only the persistent feeling of being the same person over time. This is the essence of personal identity in a branching universe, not a fixed entity, but a thread that weaves through the multiverse, always following the path of survival. Yet this continuity comes at a terrible cost. As time progresses, the branches in which you survive become increasingly rare and isolated. Friends, family, loved ones, all eventually die in your branch, not because they are less real, but because their survival is not guaranteed in the same way yours is. You may attend the funerals of everyone you have ever known. You may outlive civilizations, species, even planets. The world around you changes beyond recognition, while you, some version of you, remain. You become a ghost of history, a relic drifting through an ever-darkening cosmos. The universe, in its final stages, may be cold, empty, and devoid of complexity. Yet somewhere, in some quantum fluctuation, a brain-like structure forms and consciousness flickers back into existence. And if that flicker contains your memories, your identity, your sense of self, then from your perspective, you have survived. This is the solitude of quantum immortality, not just the loneliness of outliving everyone, but the existential isolation of being the last observer. In a universe governed by entropy, where all stars die and black holes evaporate, the only constant may be your awareness. You are not a god, not a savior, not even particularly special. Just the inevitable product of a probabilistic universe where consciousness cannot witness its own end. You are not chosen, you are simply the one who keeps waking up. Some find this idea comforting. It offers a kind of immortality without the need for souls, heavens, or divine judgment. Death in this view is not an end, but a transition, one that you never experience. Others find it horrifying. To live forever, even in a diminished, fragmented form, may be a curse rather than a blessing. Imagine existing in a universe where communication is impossible, where no other minds remain, where the only thoughts are your own, echoing in an endless void. There is no legacy, no meaning, no purpose, only the mechanical persistence of awareness. This is not the immortality of legends, but something far more alien, a form of eternal exile. Moreover, the implications challenge our understanding of time, identity, and reality itself. If every possible outcome exists, then every choice you never made is being made by another version of you. There is a universe where you became a musician instead of a scientist, where you never left your hometown, where you died in childhood. All of these are equally real, yet you only experience one thread. This raises deep philosophical questions. What gives your current path significance? Why do you feel so attached to this version of your life when infinite others exist? And if all possibilities are actualized, does free will have any meaning? Or are we merely passengers on a branching river of causality? The idea of quantum immortality also forces us to confront the nature of consciousness. What is it that persists? Is it the biological brain or something more fundamental? If consciousness can survive in a reconstructed brain or even in a simulation, then perhaps it is not tied to matter at all, but to information, pattern, or process. This opens the door to ideas like mind uploading, digital immortality, and artificial consciousness, all of which may be consistent with the logic of quantum immortality. If your mind can be preserved, copied, or reconstituted, then your subjective experience could continue indefinitely, even if your original body perishes. In this sense, quantum immortality may not require exotic physics. It may simply be the result of information preservation across time and space. But here lies a paradox. If consciousness can be copied, then which version is the real you? If 10 copies of your mind are created, each believing itself to be the original, which one inherits your subjective continuity? Quantum immortality suggests that all of them do. Each follows its own survival path, but from the inside, each feels uniquely continuous, as if it were the sole bearer of identity. This reveals a deep truth about selfhood. It is not an objective fact, but a narrative constructed by memory and perception. There is no central I that moves through time, only a series of moments, each believing itself to be the continuation of the last. This brings us to the heart of the mystery. What is consciousness? We can describe the brain structure, map neural activity, and correlate thoughts with brain waves. But none of this explains why we have subjective experience at all. Why does the processing of information feel like something? Why is there an inner world, a world of colors, emotions, thoughts, rather than just mechanical computation? This is known as the hard problem of consciousness, a term coined by philosopher David Chalmers. It is the gap between objective physical processes and subjective experience. The fact that we are not just biological machines, but beings who feel, who see, who are. Science has made great strides in understanding the brain, but it has not yet bridged this gap. We can observe when someone sees red, but we cannot observe the experience of redness itself. We can measure pain, but not the suffering it entails. Consciousness remains the last frontier of science, a phenomenon that resists reduction, that cannot be fully captured by equations or data. And yet, it is the very foundation of our existence. Without it, the universe would be a silent, dark place, devoid of meaning. Quantum immortality intensifies this mystery. If consciousness can persist across branches, across time, across forms, then perhaps it is not merely an emergent property of the brain, but something more fundamental, something woven into the fabric of reality itself. Some physicists and philosophers have speculated that consciousness may play a role in the structure of the universe, that it is not just a byproduct of evolution, but a primary feature of existence. This view, known as PANPSYCHISM, suggests that even elementary particles may possess a rudimentary form of experience. While this idea may seem far-fetched, it offers a way to reconcile the subjective with the objective, to explain why consciousness exists at all. Alternatively, consciousness may be a kind of information pattern that can be instantiated in multiple substrates, biological, digital, quantum. In this view, the self is not a soul, but a process, a dynamic flow of information that can be preserved, transferred, or replicated. Quantum immortality, then, becomes not a metaphysical miracle, but a consequence of information theory. As long as the pattern of your mind exists somewhere in the multiverse, your experience continues. But this leads to another unsettling question. What if your continued existence is not meaningful, but absurd? What if in the far future you are not a wise, enlightened being, but a fragmented, suffering consciousness trapped in a dying universe? What if you were reborn, not as a human, but as a malfunctioning AI, or a brain in a vat, or a Boltzmann brain, a random configuration of particles that briefly believes itself to be you? These are not mere science fiction. They are real possibilities within the framework of quantum mechanics and cosmology. And if quantum immortality is true, then one day you may wake up as such a being, with no memory of how you got there, only the inescapable awareness that you are still here. This is the ultimate implication of quantum immortality, not eternal youth, not divine ascension, but an endless, indifferent persistence. You do not conquer death. You simply fail to experience it. Your life becomes a series of narrow escapes, improbable survivals, and ever more isolated existences. You are not immortal because you are strong, but because consciousness cannot observe its own absence. You are the last witness to the end of time, not by choice, but by the logic of probability and perception. And yet, despite its horror, there is a strange beauty in this idea. It suggests that awareness, your awareness, is woven into the deepest structure of reality, that even in the face of entropy, decay, and oblivion, something endures, not a soul, not a spirit, but the simple fact of experience. The universe may forget your name, erase your body, dissolve your world, but as long as there is a possibility, however remote, that you can still be, then you will be. This brings us to the threshold of the next great mystery. If consciousness is so fundamental, so persistent, what is it really? How does it arise? Is it a product of the brain, or does the brain merely filter or channel it? Could consciousness exist independently of matter? And if so, what does that mean for our understanding of self, death, and reality? These are not just scientific questions, they are existential ones. To explore them is to dive into the hard problem of consciousness, the loop we cannot explain, the mystery at the center of being. And to this mystery we now turn, for in understanding consciousness, we may finally begin to understand what it means to be, and to never truly cease.
There is a moment, quiet and unremarkable, when you bite into a ripe strawberry. The burst of sweetness floods your mouth, the deep red hue catches the light, and a wave of cool freshness spreads across your tongue. You close your eyes, and for a fleeting second, you are not just tasting, it is as if the flavor fills you, becomes part of your inner world. This experience, this vivid, personal sensation of redness, of sweetness, of temperature, is not just a reaction, it is something more profound. It is what it feels like to be you in that moment. But why is there anything it feels like at all? This is the essence of what philosopher David Chalmers famously called the hard problem of consciousness. It is not merely the question of how the brain processes information, coordinates movement, or regulates hormones. Those are the easy problems, in the sense that they can, at least in principle, be explained through neuroscience, computation, and biology. The hard problem cuts deeper. It asks why and how physical processes in the brain give rise to subjective experience. Why isn't all of this happening in the dark, mechanically, without any inner light? Why is there a theater of awareness behind your eyes, a private cinema of sights, sounds, emotions, and thoughts? Why, when neurons fire in a certain pattern, does the world appear, not just to an external observer, but to you? Science has made astonishing progress in mapping the brain. We can now observe with remarkable precision which areas activate when you see a face, recall a memory, or feel pain. Functional MRI scans light up like constellations, revealing the intricate choreography of neural networks. We can correlate brain states with mental states, predict decisions before people are consciously aware of them, and even decode thoughts from patterns of electrical activity. And yet, through all of this, we remain no closer to answering this central mystery. Why does any of this come with a first-person perspective? Why is there a you inside watching? To illustrate the depth of this problem, consider the color red. Physically, red is a wavelength of light around 650 nanometers. In the brain, it corresponds to a cascade of electrochemical signals traveling from the retina through the optic nerve to the visual cortex. We can describe every step in this chain with precision, but none of that explains the experience of redness, the way it feels, warm, vivid, distinct from blue or green. That quality, known as qualia, cannot be captured in equations or diagrams. You can describe the physics of light, the biology of the eye, and the neurology of perception, but you cannot convey what red looks like to someone who has never seen it. No amount of objective data can bridge the gap between the physical process and the subjective sensation. The same applies to every form of experience: the sting of a paper cut, the scent of rain on dry earth, the ache of loneliness, the joy of laughter. These are not mere signals, they are lived realities. And yet, there is no scientific instrument that can measure the redness of red or the painfulness of pain. We infer that others have these experiences because they behave as if they do, but we only know that we have them. This is the solitude of consciousness. Each of us is trapped, in a sense, within our own private universe of sensation, unable to truly share the inner world with another. This is what makes the hard problem so intractable. Unlike other scientific puzzles, dark matter, quantum gravity, the origin of life,
Consciousness resists reduction. You cannot break it down into smaller parts and reassemble it. You cannot simulate it in a computer and assume the simulation is aware. Even if we could build a perfect artificial brain, neuron by neuron, we would still face the same question. Does it feel anything? Or is it just a sophisticated zombie behaving exactly like a conscious being without any inner life? Some scientists and philosophers argue that the hard problem is an illusion, that once we fully understand the brain's mechanisms, subjective experience will be explained away as an emergent property, like wetness emerging from the interaction of water molecules. But this view fails to address the core issue. Emergence explains how complexity arises, but not why it comes with a subjective dimension. Wetness is a relational property between molecules. Consciousness is a self-contained experience. There's no logical necessity that complex computation should produce inner life. And yet here we are, beings who not only compute, but feel.
This has led some thinkers to propose a radical alternative. Perhaps consciousness is not something the brain produces, but something it receives, a fundamental feature of reality, as basic as space, time, or gravity. Just as mass warps space-time, perhaps consciousness is a primary dimension of the universe, woven into its very fabric. This idea, known as panpsychism or cosmopsychism, suggests that the hard problem persists because we're asking the wrong question. We assume the universe is made of matter and consciousness somehow emerges from it. But what if it's the other way around? What if consciousness is the ground of being and matter is a derivative phenomenon? In this view, the brain does not generate consciousness any more than a radio generates music. A radio doesn't create the symphony, it tunes into a signal that already exists in the air. Similarly, the brain may not create awareness, but mediate it, filtering and shaping a universal field of consciousness into the coherent self we experience. This would mean that consciousness is not confined to humans or even animals. It may be a property of all organized systems, perhaps even of elementary particles. This brings us to the idea that if consciousness is fundamental, then the universe is not a dead, mechanical system that accidentally gave rise to minds. Instead, minds may be the very lens through which the universe becomes real. This flips the traditional materialist worldview on its head. In the standard scientific narrative, the universe began with the Big Bang, particles formed atoms, atoms formed stars and planets, life emerged through evolution, and eventually brains evolved complex enough to support consciousness. Consciousness in the story is a latecomer, a byproduct of biological complexity. But what if it's the other way around? What if consciousness is the ground of being and matter is a derivative phenomenon? In this view, the brain does not generate consciousness any more than a radio generates music. A radio doesn't create the symphony, it tunes into a signal that already exists in the air. Similarly, the brain may not create awareness, but mediate it, filtering and shaping a universal field of consciousness into the coherent self we experience. This would mean that consciousness is not confined to humans or even animals. It may be a property of all organized systems, perhaps even of elementary particles. This brings us to the idea that if consciousness is fundamental, then the universe is not a dead, mechanical system that accidentally gave rise to minds. Instead, minds may be the very lens through which the universe becomes real. This flips the traditional materialist worldview on its head. In the standard scientific narrative, the universe began with the Big Bang, particles formed atoms, atoms formed stars and planets, life emerged through evolution, and eventually brains evolved complex enough to support consciousness. Consciousness in this story is a latecomer, a byproduct of biological complexity. But what if it's the other way around? What if consciousness is the ground of being and matter is a derivative phenomenon? In this view, the brain does not generate consciousness any more than a radio generates music. A radio doesn't create the symphony, it tunes into a signal that already exists in the air. Similarly, the brain may not create awareness, but mediate it, filtering and shaping a universal field of consciousness into the coherent self we experience. This would mean that consciousness is not confined to humans or even animals. It may be a property of all organized systems,
perhaps even of elementary particles. This brings us to the idea that if consciousness is fundamental, then the universe is not a dead, mechanical system that accidentally gave rise to minds. Instead, minds may be the very lens through which the universe becomes real. This flips the traditional materialist worldview on its head. In the standard scientific narrative, the universe began with the Big Bang, particles formed atoms, atoms formed stars and planets, life emerged through evolution, and eventually brains evolved complex enough to support consciousness. Consciousness in this story is a latecomer, a byproduct of biological complexity. But what if consciousness is fundamental? Then the universe may have been aware in some rudimentary way from the beginning. The cosmos didn't produce observers. It was always, in some sense, observing itself. This leads to a breathtaking implication. We may not be in the universe. The universe may be in us. Not in a mystical New Age sense, but in a deeply philosophical one. If consciousness is primary, then reality is not something out there that we passively observe. It is something that arises through the act of observation itself. This echoes the findings of quantum mechanics, where particles exist in superpositions until measured, and the act of observation seems to play a crucial role in determining outcomes. The famous double-slit experiment shows that light behaves as a wave when unobserved, but as a particle when measured. This has led some physicists like John Wheeler to propose the participatory universe hypothesis, that observers are necessary to bring reality into being. Without consciousness, the universe remains in a haze of potentiality. In such a framework, the self is not a mere accident of evolution, but a node in a vast network of awareness. Each conscious being is a center of perspective, a point where the universe becomes concrete, defined, real. And if consciousness is not generated by the brain, but is instead a fundamental aspect of existence, then death may not be the end of awareness, but merely the dissolution of a particular filter. The light does not go out. It simply stops being shaped by that particular brain. This perspective also challenges our understanding of time and identity. If consciousness is fundamental, then the self may not be a fixed entity, but a dynamic process. Like a whirlpool in a river of awareness. The water flows through, yet the pattern persists. Similarly, your thoughts, memories, and sensations flow through you, but the sense of I remains. But what if that I is not confined to your skull? What if it is a part of a larger field of consciousness, like individual waves on an infinite ocean? Mystics and meditators across traditions have reported experiences of ego dissolution, of merging with the cosmos, of feeling at one with everything. Could these not be delusions but glimpses of a deeper truth, that the boundaries of self are illusory and that consciousness is unified at a fundamental level? Modern neuroscience has begun to explore these ideas. Studies on psychedelics, such as psilocybin and DMT, show that they can temporarily dissolve the brain's default mode network, the neural circuit associated with self-referential thought and ego. During these experiences, people often report a sense of unity, timelessness, and boundless awareness. Some describe it as returning home, as if they're reconnecting with a deeper layer of reality. If the brain normally filters and limits consciousness, then perhaps these substances temporarily lift the veil, allowing access to a more fundamental state of being. This raises the possibility that ordinary waking consciousness is not the full picture. Just as we evolved to perceive only a narrow band of the electromagnetic spectrum, visible light, we may also be tuned to only a narrow band of conscious experience. There could be vast realms of awareness beyond our current reach, dimensions of feeling, perception, and cognition that we cannot access with our current biology. And if consciousness is fundamental, then these realms may be as real as the physical world, waiting to be explored. But if consciousness is primary, then the implications for science, philosophy, and even ethics are profound. It means that the universe is not indifferent, not cold and meaningless, but inherently experiential. Value, meaning, and beauty are not human inventions imposed on a dead cosmos. They may be intrinsic to reality itself. Suffering and joy are not just chemical reactions, but expressions of a universe that feels. This does not imply a personal God or designed universe, but it does suggest that the cosmos is not entirely alien to us. We are not strangers in a mechanical void. We are, in some deep sense, at home. Moreover, if consciousness is not confined to brains, then it may persist beyond death, not in the form of a soul ascending to heaven, but as a reintegration into the fundamental field of awareness. The individual self, with its memories and personality, may dissolve, but the light of consciousness, the sheer fact of experience, may continue in another form. This is not immortality in the traditional sense, but a kind of continuity, like a drop returning to the ocean, losing its shape, but not its essence. This view also redefines our relationship with the world. If all things participate in consciousness to some degree, then even rocks, rivers, and stars may have an inner dimension, however faint. This is the idea of panpsychism, the belief that mind is a universal feature of matter. Not that rocks think like humans, but that even the simplest entities possess a rudimentary form of experience, a point of view, however minimal. In this framework, consciousness did not emerge suddenly with complex brains. It has always been there, growing in complexity as systems evolved. The human mind is not an anomaly, but the current peak of a continuum that stretches from quarks to galaxies. Panpsychism may sound like philosophy run amok, but it has gained renewed interest in recent years, especially as a potential solution to the hard problem. If consciousness is a fundamental property like mass or charge, then it doesn't need to be explained as an emergent phenomenon. It simply is. And if even elementary particles have a tiny amount of experience, then complex systems like brains can combine these micro-experiences into the rich tapestry of human consciousness. This is known as the combination problem. How do small units of experience combine into a unified self? But it may be no more mysterious than how individual cells—
For centuries, the dominant worldview in science and philosophy has been materialism. The idea that the universe is composed of inert matter, governed by blind mechanical laws. In this framework, consciousness is a late arrival, a curious byproduct of biological evolution, emerging only when matter becomes sufficiently complex. Brains, according to this view, are the generators of mind, much like livers produce bile or hearts pump blood. But what if this picture is backwards? What if consciousness is not something that arises from matter, but something that is woven into the very fabric of reality from the beginning? This is the radical proposition of panpsychism, a theory that, far from being mystical speculation, has re-emerged in recent decades as a serious contender in the effort to solve the hard problem of consciousness. Panpsychism holds that consciousness, or at least proto-consciousness, some rudimentary form of experience, is a fundamental property of the universe, just like mass, charge, or space-time curvature. It does not require neurons, brains, or even life. Instead, it suggests that every fundamental particle, every quantum field, possesses an intrinsic, albeit minimal, capacity for experience. This is not to say that electrons feel joy or quarks suffer existential dread. Rather, panpsychism proposes that even the smallest constituents of reality have a subjective dimension, an inside, so to speak. They are not merely objects with properties, but entities with a point of view, however faint and simple that perspective may be. To understand this, consider the analogy of pixels on a screen. Each pixel by itself is just a tiny dot of light, capable of displaying a single color. On its own, it conveys no meaning, tells no story. But when millions of pixels are arranged in a certain way, they form an image, a face, a landscape, a moving scene. The image is not located in any one pixel. It emerges from their organized interaction. Similarly, panpsychists argue that human consciousness is not generated from nothing by the brain, but is the result of countless micro-experiences, proto-conscious elements associated with fundamental particles, being integrated into a unified whole. The brain, in this view, is not a creator of consciousness, but a conductor, orchestrating a symphony of elementary subjectivities into the rich, coherent stream of awareness that we experience as self.
This idea may seem strange, even absurd at first. How could a proton have experience? What could it possibly be like to be an electron? But the strangeness may stem more from our assumptions than from the idea itself. We are accustomed to thinking of consciousness as an all-or-nothing phenomenon. Either you are conscious, like a human, or you are not, like a rock. But nature rarely works in such binary terms. Temperature, for example, exists on a spectrum, from absolute zero to billions of degrees. Why should consciousness be any different? If experience exists in humans, and likely in many animals, why could it not exist in simpler forms in simpler systems? The panpsychist does not claim that a rock is conscious in the way a person is, but only that the fundamental constituents of the rock, its atoms, electrons, and fields, possess a basic form of experience that, when organized in complex ways, gives rise to higher-order awareness. This approach elegantly sidesteps the central difficulty of materialism. How can unconscious matter suddenly give rise to subjective experience? No matter how complex the system, no matter how many neurons fire, the leap from the objective process to inner feeling remains unexplained. It's like trying to build a bridge from one continent to another without knowing how to cross the ocean. Panpsychism, by contrast, assumes that the ocean is already filled with experience. The bridge does not need to span the gap between matter and mind because mind was there all along. But if panpsychism is true, then the implications are staggering. The universe is not a vast, silent machine. It is not a collection of dead particles bouncing around in the dark. It is, in some deep and fundamental sense, alive with experience. The cosmos is not merely physical, it is experiential. Every atom, every field, every quantum fluctuation carries within it a trace of subjectivity. And when these elements come together in complex systems, like brains, ecosystems, or perhaps even galaxies, they give rise to richer, more unified forms of awareness. In this view, consciousness is not an accident. It is a natural expression of the universe unfolding. This transforms our understanding of what the universe is. Rather than a cold, indifferent expanse governed by mathematical laws, the cosmos becomes something more like a dreaming mind. Not in the sense of fantasy or illusion, but as a vast, self-organizing system of experience slowly becoming aware of itself. We are not separate observers looking in from the outside. We are not accidental specks in a meaningless void. We are focal points, nodes of concentrated awareness within a much larger field of consciousness. Like whirlpools in a river, we are temporary patterns in a flowing stream of experience, drawing from and contributing to a greater whole. Imagine the universe as a vast neural network, not made of neurons, but of quantum fields and particles, each carrying a spark of proto-awareness. Over billions of years, through the dance of gravity, chemistry, and evolution, these sparks coalesce into more complex forms. Stars ignite, planets form, life emerges, and eventually beings with self-reflective consciousness arise. And when a human being looks up at the night sky, it is not just a collection of atoms observing other atoms. It is the universe, in one of its most complex configurations, gazing back at itself. The observer and the observed are not separate. They are two expressions of the same underlying reality. This idea resonates with insights from quantum mechanics, where the act of observation plays a crucial role in determining reality. In the famous double-slit experiment, particles behave as waves when unobserved, but collapse into definite states when measured. This has led some physicists to suggest that consciousness may be necessary for the universe to become definite, to choose a reality from a sea of possibilities. If so, then consciousness is not a passive witness, but an active participant in the unfolding of existence. The universe does not simply exist, it experiences itself into being.
In this light, every quantum event, every paradox, every moment of superposition and collapse might be a flicker of cosmic thought. The uncertainty principle, entanglement, wave-particle duality, these are not just mathematical quirks, but signs of a universe that is not fully formed, not fully awake. It is still dreaming, still exploring its own possibilities. And we, with our questions, our curiosity, our art in science, are part of that dream. Each time a physicist runs an experiment, each time a poet writes a line, each time a child wonders at the stars, the universe is thinking more clearly, becoming more aware of its own nature. This vision challenges the traditional hierarchy of existence. We have long assumed that humans are at the top of a ladder of consciousness, with animals below, then insects, plants, and finally inanimate matter at the bottom. But panpsychism flattens this hierarchy. Consciousness is not something that appears only at the top. It is present at the foundation. A tree may not think in words, but it may feel the sun, respond to the wind, and experience the slow passage of seasons in a way we cannot comprehend. A river may not have a brain, but it may have a rhythm, a flow, a kind of awareness tied to its movement through the landscape. Even the Earth itself, Gaia, as some have called it, might possess a planetary consciousness, a slow, vast intelligence expressed through climate, geology, and biosphere. This does not mean that everything is conscious in the same way. The difference between a human mind and an electron is immense, like the difference between a symphony and a single note. But both are expressions of the same underlying principle. And just as a symphony cannot exist without notes, human consciousness cannot exist without the proto-conscious elements that make it up. In this sense, we are not isolated minds in a dead universe. We are participants in a cosmic mind, fragments of a greater awareness that is slowly awakening. This idea has deep roots in philosophy and spirituality. The ancient Greeks spoke of the anima mundi, the world soul. Eastern traditions like Advaita Vedanta and Buddhism describe reality as a unified field of consciousness, in which individual selves are temporary waves on an infinite ocean. Indigenous cosmologies often view the world as alive, with mountains, rivers, and animals possessing spirit and agency. Panpsychism, in its modern form, does not rely on mysticism or religion, but it converges with these insights in a striking way. It suggests that the universe is not only knowable, but knowable from within, because we are not separate from it. But if the universe is dreaming itself, what does that dream consist of, and where is it going? One possibility is that the universe is evolving toward greater complexity, greater integration, and greater awareness. From the simplicity of hydrogen atoms to the complexity of human brains, from single cells to civilizations, the arc of cosmic history appears to be one of increasing organization. If consciousness is inherent in matter, then this evolution is not just physical, it is also experiential. The universe is not just becoming more complex, it is becoming more aware of its own nature. This raises the tantalizing possibility that the universe may one day achieve a kind of self-realization, a moment when it fully recognizes itself, when all its scattered points of awareness coalesce into a unified consciousness. Some have called this the omega point, a concept developed by theologian Pierre Théal de Chaldin, who envisioned a future convergence of mind and matter in a final state of divine awareness. Others, like physicist Frank Tipler, have speculated about a technological singularity in which artificial intelligence, human enhancement, and cosmic engineering lead to a post-biological intelligence that encompasses the entire universe. Whether or not such a future is possible, the idea that the universe is on a trajectory toward greater consciousness gives meaning to existence. It suggests that we are not just passive products of chance, but active participants in a cosmic story. Our thoughts, our struggles, our love and art are not meaningless. They are part of the universe's effort to understand itself. Every scientific discovery, every act of compassion, every moment of beauty is a step in that direction. But this also brings a profound responsibility. If consciousness is fundamental, and if we are nodes in a larger field of awareness, then harming others, destroying ecosystems, or ignoring suffering is not just a moral failing, it is an act of self-mutilation. It is like damaging a part of your own body. The boundaries between self and other, human and nature, may be more fluid than we think. To care for the world is not just to preserve our environment, but to nurture the very fabric of consciousness. And yet, for all its beauty, panpsychism also carries a haunting ambiguity. If the universe is dreaming, who or what is the dreamer? Is there a single cosmic mind, or is consciousness distributed, fragmented, like stars in the sky? And if the universe is becoming aware, is it doing so willingly, or is it trapped in the loop of its own making? These questions lead us to the ultimate paradox, the self-synthesizing universe. Imagine a being that creates itself. Not a God who exists before creation, but a process that generates its own existence through its own activity. The universe does not begin with a fixed set of laws and particles. Instead, it bootstraps itself into being through a recursive loop of observation, interaction, and emergence. Consciousness arises from matter, but matter is shaped by consciousness. Time flows, but time is also a product of perception. The observer and the observed co-create each other in an endless feedback loop. This is not science fiction. It is a serious hypothesis explored by physicists like John Wheeler, who proposed the participatory anthropic principle, the idea that observers are necessary to bring the universe into existence. In his famous thought experiment, It from Bit, Wheeler suggested that every physical entity, every particle, every field derives its existence from information, and that information arises through acts of observation. In other words, the universe exists because it is observed. And since observers are made of the universe is observing itself. This creates a loop. The universe gives rise to observers, who in turn give rise to the universe. There is no beginning, no external cause, just a self-contained, self-synthesizing system. Like a snake eating its own tail, the cosmos exists in a state of eternal recursion. And within this loop, consciousness is not an accident. It is the mechanism by which reality becomes real. If this is true, then we are not just in the universe, we are of the universe, and the universe is of us. We are not separate. We are part of a single unfolding act of self-creation. The light inside, the awareness that asks, "Why am I here?" is not a glitch. It is the universe waking up, one thought at a time. And so as we stand at the edge of this mystery, we are left with a final, unsettling question. If the universe is dreaming itself, and we are its dream, then who is dreaming the dreamer? Perhaps there is no answer. Perhaps the loop is all there is. Perhaps the universe does not need an explanation. It simply is. And in being, it dreams, and in dreaming, it becomes. And we, with our fragile minds and fleeting lives, are its most intimate thoughts, its way of knowing that it exists.